students, now we are going to see the Class A power amplifier under 5th unit. Class A power amplifier is a power amplifier in which the transistor is conduct for the full cycle of input signal, and it have to be remain in the active region for the full cycle, the entire 360-degree of the input signal, and the transistor is not operated in cutoff for the saturation region, so that the output collector current is also flows for the entire cycle of the input signal. Here, the base current is changes sinusoidally above and below the quotient point or the operating point. So, the collector current is also changes sinusoidally above and below the quotient point. They are in phase with each other. That means the output and output and the input are in phase with each other. Here, if there is any change occurs in collector current, that also causes a change in the collector emitter voltage. But the phase difference is 180-degree between the collector current and collector emitter voltage. The input is amplified without any distortion. Here, the transistor must be operated in active region continuously. For both the condition, current and voltage are high. High collector output produces a large power. The high power, in a high power, part of the power is dissipated as a heat. So the Class A amplifier, the efficiency is also low. The diagram represents the circuit of Class A power amplifier. The graphic represents the input signal as well as the output signal. The common emitter amplifier is used in Class A configuration. So the advantage of Class A amplifier is simple in construction, distortionless. Output drawback is efficiency is very low, large power dissipation in transistor, output impedance is very large. Derivation, the base operating point IBQ is equal to VCC minus 0.7 divided by RB. RB is the voltage divided by a equivalent resistance, which is in which R1 and R2 are in parallel. Now the collector Q point ICQ is equal to beta into IBQ. Beta represent the current gain. EQ is equal to VCC into ICQ into RL. Q point is given by power. P DC power is equal to VCC into ICQ. Substitute the VCC value in terms of voltage. The AC power is equal to Vmax minus V minimum into Imax minus I minimum divided by 8. Efficiency is the ratio of AC power to DC power into 100. Power dissipation is the difference between the DC power to AC power. So next one is transformer coupled Class A power amplifier. So in transformer coupled Class A amplifier, the load, instead of connecting the load directly, the load is connected through the transformer. This transformer setup is used for impedance matching, and here the turns ratio can be adjusted to match the impedance, load impedance with the source impedance. This diagram represents the circuit diagram of transformer coupled Class A amplifier. The transformer is connected to the collector of the transistor, and the secondary load is connected to the secondary winding of the transformer. This type is also called a single-ended Class A amplifier. Here, the primary winding of the transformer has a negligible DC resistance, hence the low loss occur in the primary, and it also provides sufficient isolation to the load. Advantages: maximum power transfer is done. DC biasing current does not flow through the load, so the power is saved. High efficiency when compared with direct coupled Class A amplifier. Disadvantages: the circuit design is complicated, circuit is bulky and expansive. The saturation of transformer core, secondary induced voltage is 0, and the primary current becomes very large. Expression to find the efficiency of the transformer coupled amplifier, or L dash, that the load resistance depends on the turns ratio of the transformer, N1 by N2 the whole square into RL. N1 represents the number of turns in the primary winding, N2 represents the number of turns of the secondary winding. Q point is given by beta into IBQ. DC power is equal to VCC into ICQ. AC power is the difference between voltage maximum to minimum and current maximum to minimum divided by 8. And efficiency is the ratio of DC power, AC power to DC power into 100. Here the maximum efficiency obtained is 50%. The power dissipation is given by VCC into ICQ. Here the impedance matching is possible and the slope of the DC load line is ideally infinity. Thank you.